Hello, I'm Alicia DeVos, and today I'm going to present on the paper Everyday Algorithm Auditing, Understanding the Power of Everyday Users in Surfacing Harmful Algorithmic Behavior, done with collaborators Huang Shen, Motahari Aslami, and Ken Holstein. You might have heard last year about how racial bias was found in Twitter's image cropping algorithm. What happened was this. A Twitter user noticed an issue. He tweeted this photo. Since it's too wide to appear in a tweet's thumbnail preview, Twitter cropped the image for that preview to look like this. This prompted the user to notice unexpected behavior and theorize that Twitter's cropping algorithm might be racially biased. The user tweeted about this as well, saying, geez, any guesses why Twitter defaulted to show only the right side of the picture? Then the user started testing hypotheses of racial bias by tweeting the same image as before, but flipped, so the person on the right was now on the left and vice versa, and got similar results. Others on Twitter joined in, tweeting images of their own creation to see what the image cropping algorithm would prioritize and what the algorithm would crop out. This is one example of one test that became very popular in which Obama and McConnell were put together in long images to see what the cropping algorithm would do, which was mostly focused on McConnell. Ultimately, Twitter users concluded that Twitter's image cropping algorithm was prioritizing white people over Black people. This incident occurred even though Twitter stated that it had tested the image cropping service for bias before it started using it. Attempts like this to detect biased, discriminatory, or otherwise harmful behaviors in algorithms are known as algorithm audits and are typically led by experts such as industry practitioners like the Twitter developers. But why didn't the Twitter developers' algorithm audit find this issue with the image cropping while Twitter users were able to find it? This stems from the fact that traditional algorithm audit techniques, usually led by experts, have limitations. For one, algorithm audits often fail to anticipate harms and biases that only arise or may only be recognized as harmful when a system is used in the presence of particular real-world social or cultural dynamics. Another issue can arise if those involved lack the relevant cultural background and lived experience to notice harmful behaviors or know where to look for them. And lastly, new issues can emerge as a result of changing norms and practices around the use of algorithmic systems over time. We see these issues manifested in the Twitter cropping case. I've talked about the Twitter case, but that's not the only case where this user-driven auditing has appeared. In recent years, there have actually been a number of similar cases in which everyday users detected and investigated potential issues in algorithmic systems. How might we empower everyday users' motivation and strengths in surfacing harmful algorithmic behaviors in order to overcome the limitations of existing auditing approaches? How can we learn from the process of this behavior to facilitate more of it in the future? How can we better support everyday users in their detecting, reporting, and theorizing about harmful algorithmic behaviors? To answer these questions, we first need to understand how these audits happen today, as there has not been a rigorous conceptual framing of this phenomenon. How does this happen? How do everyday users go about their investigations? To describe this behavior, we developed the concept of everyday algorithm auditing, which we define as the ways everyday users detect, understand, and/or interrogate problematic machine behaviors via their day-to-day interactions with algorithmic systems. Since everyday algorithm auditing is an emerging phenomenon, the conceptual boundaries are somewhat fluid, so we scope the concept broadly to include any actions taken by everyday users to notice, interpret, question, or bring attention to problematic algorithmic behaviors. We highlight three key aspects of everyday algorithm auditing to help clarify its scope. The first is what algorithmic expertise the everyday users have. While everyday algorithm auditing is defined by everyday use, this does not mean that the users engaging in these behaviors necessarily lack technological skills. The next is the extent to which an everyday audit represents a collective effort. Some cases are more individually led, while others are more collective. The third aspect is how organic the entire process is. Some everyday audits begin with outside intervention, but then become more organic and user-led over time. Others start organically, but later turn highly organized. Still others are organic throughout the entire process. In this talk, I'll first go over the method by which we selected the cases we examined. Then I'll discuss a set of broader lifetime dynamics that emerge from examining the progression of these cases. Finally, once we've better understood the characteristics, dynamics, and progression of everyday algorithm auditing practices, I'll talk about some opportunities for future work to help us understand how we might support everyday auditing behavior to overcome the limitations of existing auditing approaches. To better understand the characteristics, dynamics, and progression of everyday algorithm auditing practices, we adopted an exploratory case study approach. Our search for recent prominent cases yielded 15 cases that met our definition for everyday algorithm auditing. These cases span multiple algorithmic domains, including image cropping, online rating and review, advertising and recommendation systems, and credit scoring. We expect that this set is not comprehensive of all everyday algorithm audits and represents only a thin slice of what is possible for everyday algorithm audits in the future. From these 15 cases, we chose a subset of 4 to examine in detail. We chose the cases to span 2 different algorithmic domains, image cropping algorithms and rating platform algorithms. We also chose the cases to vary in their levels of the key aspects discussed earlier, that is, algorithmic expertise, collectiveness, and organicness. This table shows our 4 primary case studies across those 3 aspects. Darker shades represent higher levels along a given aspect, while lighter shades represent lower. As you can see by the shading in this table, our 4 cases, as well as everyday algorithm audits more broadly, can vary among these dimensions. Our selection resulted in the Twitter racial cropping bias case, which I described at the beginning of this talk, a similar case involving potential gender bias in the Twitter image cropping algorithm, a time when small business owners on Yelp came together to investigate Yelp's potential bias against businesses that don't advertise with Yelp, and a case where a group of users on Booking.com looked into the hotel rating algorithm after the ratings didn't match their expectations. For each of these 4 cases, we gathered and reviewed discussion threads from the platforms where the everyday audits took place, then supplemented this by drawing on other relevant media such as news articles or academic publications. This helped us to better understand the lifetime and dynamics of everyday algorithm audits, which I'll talk about next. We observed phases of an everyday algorithm audit, ranging from initiation of an audit to raising awareness about observed issues, to hypothesizing about observed behaviors and testing an algorithmic system, to some form of remediation. In practice, everyday algorithm audits may not follow these phases in order or reach all phases, but the phases provide a useful high-level understanding for describing the paths that can be taken, for comparing different everyday audits, and for envisioning interventions to facilitate such audits. While I'll use the Twitter racial bias case as an example here, in the paper we discuss more cases. Everyday algorithm audits are often initiated by incidental exposure to problematic machine behaviors when users stumble upon concerning algorithmic behaviors amidst their day-to-day use of the system. For example, the Twitter case described earlier began when, in the course of tweeting an image, a user noticed that the person with darker skin in the image was excluded from preview thumbnails. After detecting a problematic algorithmic behavior, the initiator or initiators broadcast what has been discovered to users. In the Twitter case, this took the form of a tweet and subsequent retweets and tweets about the issue to other users. An everyday algorithm audit may progress to users forming hypotheses for the observed behavior and intentionally testing the algorithmic system to collect further evidence to confirm or invalidate each theory. One example of this in the Twitter cropping case was when users tested different variations of Obama versus McConnell images based on their hypotheses. While users tested whether the algorithm was indeed biased by skin tone, they also developed new hypotheses. Here you can see users testing whether different image heights or the contrast or the tie color mattered in the Obama-McConnell example. At its core, an everyday algorithm audit aims to instigate change based on the issues identified and investigated. For example, in the Twitter cropping case, this resulted in a response from Twitter committing to changing the way that image previews are cropped. It also led to broad social impact via greater awareness of these issues as news and other media sources published related articles about the audit. And again, while I've referred to this Twitter case as an example in this talk, we do discuss more cases in the paper. Now that we've characterized the concept of everyday algorithm auditing, I'll discuss opportunities this presents for future work to help us understand how we can effectively make use of everyday auditing behavior to overcome the limitations of existing auditing approaches. We identify 5 broad categories of potential design interventions. The first is community guidance. We observe different degrees and forms of collaboration among everyday audits. In general, more collective efforts may lead to more impactful everyday algorithm audits. One way designers might support collective auditing behaviors is to offer mechanisms that help everyday auditors guide each other's efforts, for example, through discussion. The second is expert guidance. We expect that everyday algorithm audits can benefit from expert input, though it remains unknown what forms and degrees of expert engagement may be most helpful. The next is algorithmic guidance. For certain auditing tasks, such as exploring a system's behavior, gathering evidence, or testing hypotheses, everyday auditors may benefit from algorithmic assistance. The next is organizational guidance. We observed fluid divisions of labor among users across the lifetime of an everyday algorithm audit. For example, in the Twitter cropping case, some users largely focused on tweeting images to test the cropping algorithm's behavior, while others contributed more in retweeting and raising awareness about observed issues or informing hypotheses about observed algorithmic behaviors. Designers could help guide the division of labor by encouraging everyday auditors to take on particular roles during an auditing process, especially roles that are expected to be important that might not arise organically. The last is incentivization. Exploring mechanisms that incentivize everyday auditors to have more active and sustained participation represents another major design opportunity. However, there is a risk that extrinsic rewards for algorithm auditing may reduce useful spontaneity in everyday algorithm audits or may inadvertently diminish users' existing intrinsic motivations to engage. There is also a need to incentivize developers and platforms to implement these measures and remediate issues that users uncover, for example, through raising awareness about harmful issues publicly, withholding data as leverage in data strikes, and policy, legal, and other structural interventions. Thanks for listening. I'm Alicia DeVos, and you can learn more about everyday algorithm auditing in our paper.